Record. Guys, I'm trying to make the video that's missing. And hold on, I thought I recorded it, but it didn't have any sound, so I'm trying again. Okay, so the idea is the cardiac cycle. Okay, hold on, I'm gonna double check this, so just deal with me for a minute. Okay, so Zoom, I'm screen sharing. No, I don't want to stop broadcasting. I'm recording. I think we have sound, hopefully. Okay, so let me go here. Okay, so I wrote on it, so I'm just gonna highlight it or point to it as I go. Okay, so cardiac cycle are all the events that are associated with one heartbeat. So there's a lot of different things going on in the heart. That's why there's so many slides in this, right? So there's whether the ventricles are contracting, the electrical impulse, what's going on with the pressure, what's going on with the blood. Okay, so pressure is really important. So pressure is going to drive most of it. So the big thing that you need to understand about pressure, and this is really, I think, logical, so is that when the chambers contract, pressure is going to increase. Okay, so when volume goes down, pressure goes up. And I have that on the next slide too. Okay, so this is supposed to be my ventricle. Okay, it's just one of them. So the ventricle, when it contracts, the pressure is going to go up. Okay, the change in pressure is going to make the blood move through the heart, and it's going to make the valves open and close. Okay, so when we measure pressure, we measure it in millimeters of mercury. So Hg is mercury. And so it's just like barometric pressure. Every time we measure pressure, we measure it in millimeters of mercury. Okay, to measure blood pressure, we use a sphygmomanometer, which is also a blood pressure cuff, right? That's the same thing. So whenever there are opposing pressures in play in order to get the blood out of the heart. So the great vessels have positive pressure. So the ventricles have to overcome that pressure in order to pump the blood out. Okay, so they have to do a certain amount of work to force the blood out. So here's a syringe, okay? And when we draw water up into it, as the volume increases, right, the pressure is going to decrease. Okay, and air would go in or water will go in. But when we decrease the volume, right, the pressure increases and the air or the water is going to flow out. Okay, so volume and pressure are inversely related. Okay, now in the phases of the cardiac cycle, so remember that the cardiac cycle it's a cycle, right? It's going around. So really you could, whoops, I made my arrows the wrong way. You could start and stop anywhere. But where we're going to start is called the quiescent period. Okay, so the quiescent period, I always think of it as like quiet. So you can see the words there. So all the chambers are relaxed, the valves are open, and blood is flowing into the ventricles with gravity. So it's just dumping in there. Nothing's happening. Okay, then what will happen is the atria will contract. So when they contract, in order for them to contract, the SA node, so the pacemaker has to fire, the atria depolarize, okay, so the charge goes around them. We get a P wave on the ECG, and then the atria contract. And they're gonna they're gonna force the rest of the blood, here's my yucky picture, from the atria into the ventricles. Okay, so they're gonna force the rest of it in. Okay, so then the ventricles are pretty much full. Okay, so they contain the end diastolic volume, which is about 130 milliliters of blood. Okay, then the next thing, whoops, wait a minute, I'm missing the highlighter thing, is isovolumetric contraction. Okay, so isovolumetric means there's no change in volume. So the atria repolarize and relax, the ventricles depolarize, Then we'll see the QRS complex on the ECG. Then the ventricles contract. Okay, when they contract, the pressure goes up. Okay, so volume goes down, pressure goes up. Okay, the AV valves close. Okay, we get heart sound 1, but the blood doesn't move yet. Okay, so the pressure is just building up in the ventricles. Okay, the next thing that will happen is that as the pressure goes up, the semilunar valves will open. The blood is ejected. Okay, so it's going to go out the aorta, the pulmonary trunk. Okay, the pressure will go down because the blood is being pumped out. Okay, and then there are some things that we're going to get out of it. Okay, so stroke volume is how much blood we pump out. So a normal number is about 70 milliliters at rest. There's another special number called the ejection fraction, which is stroke volume divided by the end diastolic volume. So basically it's a percentage of how much blood you could pump out of your ventricles. Okay, so if you have 130 milliliters in there, but you only can pump 70 out, you would take 70 divided by 130, okay? And it's about 54%. Okay, if you're resting, you're pumping more out, or if you're exercising rather, you're pumping more out, and it can go as high as 90%. If someone has coronary disease, it can be really low. It could be 10%. So they use this number to describe kind of like how healthy your heart is, if your ventricles are working, if your valves are working, how efficient is your heart working. Okay, the end diastolic volume is the amount that's left in the heart. Okay, so that's what's left in there. It's not getting ejected. Okay, isovolumetric relaxation of the ventricles is the next stage. Okay, so that's where we get the T wave. So in the T wave, that's when the ventricles are repolarizing and they're starting to relax. So the volume is increasing. The semilunar valves close, and that's when we get the second heart sound. That's when we get the dub. Okay, the valves stay closed, the AV valves stay closed, and the ventricles expand, but the volume isn't changing. Okay, so the blood's not coming in there yet. Okay, the way that the ventricles fill, there are actually 3 parts of it, 3 steps to it, because why would there only be one, right? Okay, so when the AV valves first open, it's like opening the floodgates. Okay, so the ventricles rapidly fill, the blood dumps in. Okay, then the next stage is called diastasis. Okay, so it's just kind of the venous return. It's not any pressure really driving it. Okay, and then the third part is when the atria contract again, and they push more blood in. They squeeze the rest of the blood from the atria into the ventricles. Okay, and at that point, we could hear S3, but we don't always hear that. Okay, now this picture kind of makes me want to cry because it is one graph, but it's got pretty much everything that's going on in your heart at the same time. Okay, so it's a little overwhelming to me. The idea is that you can see where the lub dub, the heart sounds are occurring, what's going on with the ECG, what's going on with the volumes and the pressures. It's really overwhelming. Okay, this picture is supposed to show you the relationship between what's going on in the chambers and what's happening on the ECG. Okay, so on here, right, we're going to have the atria filling. Okay, so the atria, we have depolarization, right, and then the atria contract. So we get the P wave. P wave is the depolarization, and then the contraction occurs. Okay, so here's the depolarization, here's the contraction. Okay, blood is going to go from the atria to the ventricles. Okay, so this is the P wave, and that's atria depolarizing. Okay, and then this is atrial contraction or systole. Okay, then the bottom picture, okay, the ventricles are depolarizing. Okay, and the atria are repolarizing. Okay, and that's QRS. Okay, and the ventricles, that's going to come down and go up from the bottom. Okay, then at this stage, this segment, the ventricles contract. Okay, so you can see them getting smaller. So that means pressure is going to go up, right? Okay, and then the T wave, the ventricles repolarize. Okay, and then we're flat. Okay, this is just to show you how the volumes change in the ventricles. Okay, so if you're resting, if you're just sitting, okay, in your ventricles, you're going to have what's called the ESV, so the end systolic volume. So it's what's left over after contraction. Okay, and you usually have about 60. So picture your little heart. So here's my heart, right? The ventricles don't totally empty. There's always some blood in there. That's the point. That's what this end systolic volume is. Okay, then what's going to happen is we're going to add 30 milliliters of blood about, right? And it's just passive flow. And then the atria contract and we add the rest of it. We squeeze the rest of it in. So that gives us this end diastolic volume of 130. Okay, then the ventricles contract, right? And they pump out 70. So that's stroke volume, right? So they're going to pump out 70. And then that leaves us with that 60 again, and that takes us back. So it's a cycle. Okay, now it's important to realize that both ventricles have to be pumping the same amount of blood at the same time for us to stay in homeostasis. So if you have heart disease and one side is working better than the other, it can mess things up. So here's how that can happen. So unbalanced ventricular output. So if one side is working better than the other. So if the right side is working better, the pressure backs up and the fluid accumulates in the lungs. Okay, so think about the blood goes right, lungs left, right? So if the right side is working and the left side can't keep up, it's going to back up in the lungs. Okay, then the opposite happens with the left side, right? So left, it's going to go to the body. Okay, so fluid, or you get edema in the systemic tissues if the left side is working and the right side is not. Okay, I know this is on another slide, so I'm not gonna go in another set of videos, so I'm not gonna go over that again. All right, so let's stop broadcasting. Let's stop recording.